Well, we had a great example of the future potential of this. We participated in recently with Telefonica IND. And what they did, and it wasn't strictly an OpenFlow implementation, but what they were demonstrating was an IP offload manager. And what they did was just the traffic through one node in the network, a multi-node network was monitored. And when the traffic crossed a certain threshold, another link was automatically brought up, another color. It rippled through the ROADMs, CDC ROADMs you're talking about, all switched. Everything happened 49 seconds to bring up a new network, less than a minute. And the teardown, once the traffic went below a certain threshold, it was torn down again in 4 seconds. So that was just the most basic implementation showing what could be feasible that maybe will help the people building the networks and providing services to the large data centers, how they may be able to respond to their load balancing needs without having to put up the static pipes.
If they can create the demands where there's enough reuse to be able to reuse that one once it's torn down. Right. And it's not just sitting there waiting for that same data center to need it again.
Right.
Otherwise, the operator is going to have to charge them the full price of the connectivity and the flexibility to be able to turn it up and down. Right. So it's going to get more expensive.
Even more expensive if you got to make it dynamic and yet the traffic pattern doesn't move.
Yes.
So if the traffic pattern really goes from between a half a dozen data centers and is moving around between those, at large amounts between them, then it makes sense. Like you said, if there's if there's two data centers and you're just turning it up and down, it's more expensive than just leaving it run all night long. It's like leaving the lights on, as you were talking earlier. It's easier to leave them on than it is to keep powering them on and off. And there's also this idea of multi-level domain, because today that decision has to come from somewhere else. As you said, 49 seconds is quite good. I mean, today we've looked at how are we going to reconfigure things in milliseconds, and it really isn't needed in this environment. I mean, obviously that demand was going to shift, and something new it was going to shift because it was moving other resources around. If it can trigger the transport at the same time, then we can take advantage of that. Or 49 seconds earlier, a minute earlier, the bandwidth would have been there, and it would have never known that it wasn't, if indeed you were able to schedule this. And this is where this multi-layer, multi-level control comes into play, and that's not really supported in any transport equipment today. I mean, you'd have to reuse what's already there.
Right. So, I mean, I think that is true with regards to the data center. But the other unique thing, I think, in the optical layer is in a kind of a more flexible sense. So if I want to reuse SDN and OpenFlow at an optical layer where I don't have pre-selected endpoints, but I want to, on the fly, pick new endpoints and allocate an optical connection between those 2 points, I have all of the variables that go along with calculating a light path to determine whether my light path is viable through all of the connectivities on the available route at that time. That today is not the same thing as just picking a data path on an electrical level.
Yeah, that's what's made the electrical switching so advantageous, right?
Exactly.
Because it was already nailed up, and yes, I can move it to any one of those paths as long as I had spare capacity available. And it's been done for years, right? We've had we do this across the Atlantic, across the Pacific, a number of places where we've got control planes running, domestic. That works really well, because you know it's there. Optical switches are always blind switches. You don't know for sure until you actually establish that path, whether A, it's going to work, or B, it should, or whether it's not. And I wouldn't expect that information to be advertised to the entire SDN network, right? The router's not going to care or should care whether or not it could establish another physical path. But if it's smart enough to go ask for it, then the optical layer can say, yes, I can support that, or no, I cannot.
Well, and that, I think, is a very good use of an application, a CPE, some sort of an off-board appliance that the SDN could trigger to say, is this light path available to me? To actually determine, and that could then address the differences we see between different transport vendors and their different calculations as to what thresholds are viable for a particular technology, whether they've got slightly different transponders, different characteristics on their ROADMs, even different fibers along different paths. Even if it's not the vendors, you've got a different set of parameters depending on the route you pick. And that could be done in an off-board that SDN could then trigger the calculation where the intelligence lies without having to own it.